So as we talk about error handling and exceptions handling, we also have other capabilities here. So for instance, we can use multiple catch statements. What that means? Well, there could be times when we want to be able to check for multiple possible error handling or exception handling. We could have a program that needs to check, for instance, arithmetic exceptions as well as array index out of bound exception. That means here at the bottom we could have another catch, right? An exception. If we want to add another one, we can add as many catches as we want. Okay, so for now, let's go ahead and we're gonna go ahead and use the same project here. I'm gonna comment that out so we have some space here. Let's go ahead and create a very quick, a small program here that essentially will show us how to use multiple catch statements. I'm gonna go ahead and create an int array here of just number. Okay, so I'm gonna just put a few numbers here. Let's say 4, 8, 16, 32, 64, 128, 256, and 512. Okay, that's our array int, array number here. And the next one, what we could do is, forget the semicolon. The next one, we're going to say int, kind of denominator here. So we're going to say denom, okay, like that. So the space, let's just put all, let's say here, just to be consistent, let's go like that. Okay, so we're going to say 0, 4, another 4, 0, 8. That should, here we're going to put in a for loop. We can say for int I, so there we go, 0, I, number here. Let's go ahead and change for number here. At length, all of that, that's good. Forget semicolon there. Now inside here, we're going to go ahead and say try and catch. All right, so the first one here, we can say system out, and we can go ahead and say number I. I'm going to put the divide sign there, denominator there, and we're going to put an I iterating through. We can say is, and we can say number I divide by denominator and pass the I. Okay, let's make this a little bit more readable. Okay, so there we go. So what are we doing here? Of course, we're just systeming out. We're just dividing arguments here from number array, right? Divided by the denominator array here. So in the first pass, it's going to be 0, so it's going to be 4 divided by 2, and we should have the result, right? 4 divided by 2 should be 2. Okay. And now let's go ahead and create an exception here. So this first exception is, it's not just going to be a general exception, right? So we have to call this, we're going to call arithmetic exception. Okay, so put like that. And inside here to catch, we can say system out print, and we can say something like, for instance, if something goes wrong, we can say can't divide by 0, something like that. Okay, if we run this, it works fine, except we have another problem here. There's the Java lang array index out of bounds exception. So we have a problem, even though we did take care of one try catch here, right? So we have the arithmetic exception that's taken care of. So that's why we are able to see all these results here. But the problem comes, divide. I think I see something. Can divide like this. That's how we spell it. Since we are able to take care of the arithmetic exception, well, we have another problem here, which is the out of bound index exception. And you have seen this for a bit now because I've always used this as example. And you probably should know what this means. Well, it just means that we out of bound, meaning that one of the arrays here, we are asking for an index that does not exist, right? So we're saying, give me the value at index 10, whereas our array only has up to 9. Okay, that's this problem, this error here. Now to solve this problem, we can create another catch statement here right below the first one. We can say catch. So now our next exception, obviously, this is how you can figure out what other exception name you should use. Well, you just look at the exception name here. So it's array index out of bound exception. So here we can say array, and there we go. And so just enter. Now we have that. So we can go ahead and say, for instance, here system out print ln, I should say, and go ahead and say something like no, for instance, no matching element found. That works. Okay, so now if we save this and run, look at this. Instead of that ugly error, that was handled, and we just showed, hey, no matching element found. If you feel the need to catch some other different exception, you are more than welcome to do. And this is really, really, really important, because you notice the fact that we created one exception, the arithmetic exception, that did not save us from the catastrophic problem that we kind of had here with the array index out of bound exception, right? So always keep thinking when you create these applications, when you start building applications or software in general, programming in Java, always keep thinking of other ways that you can handle exceptions that may arise when the application is running. So again, it may seem very trivial, it may seem such a very simple concept, but it's a very powerful one. As you can see, we took this application, a very simple one, from partially having a very good strategy to handle problems, exceptions, to essentially completely having all of them handled at this point. Of course, you could figure out and find others that you could handle, but as an example, I just wanted to show you that you are able, you know, you have ways to put as many catches as you can, as you want, as you need, actually. Now, there could also be other cases when, regardless of what happens, regardless of how you try and catch exceptions, how you handle that, all of that, you also would need something that would say, well, if this happens and we catch, regardless of anything that happens, this block of code needs to run. For instance, if you, for example, are writing an application that goes out in the internet and fetches, let's say, an image. In this example, you right away should notice that we need to do a lot of exception handling. Why? Well, one, I just said the keyword here was if you go out to the internet and fetch something. Well, we understand that the internet is not always reliable. In a sense that if I write an application that needs to go fetch an image anywhere in a web, that there's nothing that can always guarantee us that when we ask to go fetch that image, we'll always receive that image. Right away, when you hear that, you should think of there should be error handling going on in my code. Because simply, like I said, we just don't know whether that transaction of going from here to go and pick that image is actually going to be successful. All right. So back to that example again. So if that's the application we need to do, well, if the app goes out and fetches the image or tries to fetch something goes wrong, yes, we can go ahead and have all this catch and try and everything. But then what happens? But then we could say, well, if the application goes out, tries to get that image in a database somewhere on the internet, and something happens, we're going to handle that issue with try and catch, right? Just like this. But then we want to make sure that certain part of code runs regardless. In this case, we can say finally, there we go. This finally block of code here that says, if anything happens here, whatever happens, this will always run. Okay, so here we can say system out. Okay, so if you save now, if you go run, look, running will always run. Doesn't matter if errors are always misspelled there. Okay, doesn't matter if there are errors, we catch them or not, this will finally always run. Now, you may see, well, why is that so important? It's important because let's say if we have to close the gate or close this connection that we put together for the application to be able to go and fetch something. Let's say a better example, if we are getting stuff from database, right, and something happens, we're unable to get it, or we got it, we always need to close that connection for memory reasons. That's why we have finally keyword here, finally block, which will always run. So the code inside of this final block will always run. So in this case, if it's an application that needs to close that gate, to close that connection, this is the right place to do it, right? To close the database connection, or to close the stream, or many other things that you can do depending on what kind of applications you are building. Okay, another very important part of handling exceptions. Now that we have that covered, I will see you in the next video.